that is going to ask in the examination about the Dalton atomic theory. Okay, there are the two types of law of chemical combination that is in our syllabus. First is law of chemical combination. There are two types of law, means law of chemical combination, that is in our syllabus. The first is that law of conservation of mass, law of conservation of mass, and the second one is law of definite proportion. Right? Proportion. Okay, law of definite proportion. So the law of conservation of mass state that mass can neither be created nor destroyed during a chemical reaction. You everybody know about this one. Okay.
Yes.
You and law of definite proportion says that when a chemical compound in a chemical compound the elements are arranged. Okay. We will say that in a fixed ratio by mass. So we will say that what does the law of definite proportion states? That in a chemical compound, okay, elements are combined, are chemically, you have to word use chemically. Elements are chemically combined. Chemically combined in a fixed ratio by mass. What does this means? What does this means? This simply means that you cannot arrange the atoms like in water if I'm talking about. So this is a chemical compound. Chemical compound. And it has a formula. Like when two hydrogen atoms combine with one oxygen atom, it forms H2O. If we take the four hydrogen atoms will combine with one oxygen molecule to give two water molecules. If I carry out the molecular mass of this water, the water hydrogen has H2O, that is 1 into 2. For the hydrogen has one mass and there are two atoms, and that of oxygen is 16. One oxygen atom has mass 16. So it is 2 is to 16. Means if I take the hydrogen when it is reacting with oxygen gas, then it will gives you water. Okay, then it will gives you water. Got it? Now you know this is H2, this is oxygen gas, and they are reacting. So the same ratio will be there. That when 2 grams of hydrogens, like here, react with 16 gram of oxygen, then it will gives you 18 grams of water. And you can simplify this one by dividing it by 2. You will get when 1 gram of hydrogen will react with 8 grams of oxygen, then it will gives you 9 grams of water. Got it? Got it?
Yes, sir.
So this type of question may be asked in the examination. Okay. That when 1 grams of this one is reacting with 9 grams of this one, then uh, this is going to form. Okay. So this is the simplest issue. Now it does not mean that if you have so what does the law of definite proportions is? Law of definite proportions says that this is the fixed ratio of combining the uh, hydrogen and oxygen to form water. If we have 2 gram this one, then it will require 16 gram of oxygen and then 18 gram of water will be formed. If we have, tell me, if we need to form 14 grams, 48 grams of oxygen, then how many grams of hydrogen will be required and how many grams of water will be formed? Can you tell me? Can you tell me that if we have 48 grams of oxygen, can you tell me that how much grams of oxygen will be required? How much grams of oxygen will be required?
Sir,
Yes.
this is 5.
Why it is 5? Don't take that if we have 48 grams. 48 grams is. So can you tell me this one? Galvin, Riaz, and Rima. That if it is being given to you according to law definite proportions, if we have hydrogen gas when react with oxygen gas, then it will gives you water. So their simplest ratio is 1:8. And how we get this one? We get this water formula. We have two mass for this hydrogen atoms because we have total two hydrogens. One is carrying one, so two hydrogen is carrying two mass, and oxygen is 16. So they are the two kinds of atoms. One is hydrogen and another is oxygen. So we simply divide it by 2, will get 1:8. So this is the 1:8 ratio. Now, if we have 48 gram this one, if we have this one, then how much grams of hydrogen will be required? So this is very simple. That by what number you should multiply this 8 to get 48? You have to multiply it by 6. So multiply this also by 6. It will be 6 grams. And if you still don't know that, how you are going to find out, then what you are going to write it? You write their simplest ratio first and write it x. Okay. And write this, uh, this, uh, this is 48 I have given you. Okay. Now you need to find out that how much it is. So what you are going to write it, just cross multiply this one and equate it. Like 1 into 48 is equals to 8 into x. Just multiply this by this and this by this. Okay, and then find the value of x. This is very simple. This x will, you keep it here. This will comes down. This is 48. 1 into 48 will be 48. And this 8 will comes down. You divide it, you will get 6. So you will get x is equals to 6 gram. Got it? Yes. And how many grams of water will be formed? So this you have used 6. So 6 plus 8, 48, you will get 54. Okay, so 54 grams of water will be formed. Similarly, if I give you the next question, it is from NCRT. That for example, you have carbon, when it burns in oxygen, it will gives you carbon dioxide. Can you tell me that what is the simplest ratio of reacting with carbon and oxygen in forming the carbon dioxide? Like in hydrogen and oxygen, we have calculated. Oxygen we have calculated that is in water. We have calculated is 1:8. So please predict the simplest ratio of carbon and oxygen here in forming the carbon dioxide. Carbon and oxygen. Find out this one first. The simplest ratio of carbon and oxygen. Find out fast. You're doing?
Yes, sir. Just a second. Sir, is it 1:2?
Oh, no, it is not 1:2. Galvin, are you doing this one?
Yes,
And
sir.
Riaz, tell me, what is the simplest ratio?
I'm still doing it.
Still going there. Okay. So let's talk. This is very
Sir,
simple
is
that
it 3:8?
yes, it is 3:8. You know that carbon is 12 and oxygen is here is O2. So O2 means 632 here. You cut it by maximum number, you can cut it by 4. 4 threes are and 4 eights are. So that is 3:8. Okay. So for every 3 grams in the inside, it is given that the carbon and oxygens react together to form carbon dioxide. Means for and the ratio of their combining is 3:8. Means they combine and this with the ratio of 3:8. So if I ask you that if you have still 3 grams of 6 grams of oxygen, sorry, carbon, and 50 grams of oxygen. Okay, 3 grams of carbon, sorry, 6 grams of carbon you have, and 50 grams of oxygen gas, then how much grams of carbon dioxide will be formed? Tell me, how much grams of carbon dioxide will be formed? Tell me that how much grams of carbon dioxide will be formed if we have 6 grams of carbon and 50 grams of oxygen. How much grams of carbon dioxide will be formed? Tell me. Tell me, Rima.
Just a second, sir. Sir, it's 44.
Sir, I got 44.
What you are saying? Yes, Galvin, what are you saying?
I got
44.
44.
544. You will see that for 3 grams we require 8 gram of oxygen. Na? So for 6 gram we'll require 16 grams of oxygen. And we have extra. So it does not mean that it will be 56 grams. No. It will make 6 plus 16. You will get 22 grams. So 22 grams of oxygen will be formed. Sorry, carbon dioxide will be formed. It's 22. And the remaining 50 minus 16, that is 34 grams of oxygen will remain unreacted. Will remain unreacted. Okay. You got this one?
Yes, sir.
Yes.
This is very important that you need to understand. But in the NCERT, I changed this one. In the NCERT, it is given that the required ratio is 3:8. When 3 grams of carbon react with 8 grams of oxygen, it gives 11 grams of carbon dioxide. How many grams of carbon dioxide is formed when we have still 3 grams of carbon and 50 grams of oxygen? So still it will form 11 gram. Why? Why? Just because here this is 3 plus 50, because out of this 50 grams, only the 8 grams of carbon will oxygen will react, because for 3 grams, we require exactly 8 grams. It does not require 7, it does not require 9, it will require exactly 8. For 3, we require 8. So 8 plus 3, 11 gram is formed, and the remaining 42 grams in this case will remain unreacted. Remain unreacted. You understood? Tell me fast.
Yes.
Okay, next question if I talk about. Just a minute. So they were talking about the chemical properties, okay? And here is Dalton atomic theory, okay? Dalton atomic theory, there are the two drawbacks in the Dalton atomic theory. The drawbacks we are just going to study and the postulate. So if I talk about the Dalton atomic theory, just give me a minute. Let me have the Dalton atomic theory on the screen. So this is the Dalton atomic theory, okay? This is on your screen. This is the Dalton atomic theory. So what does Dalton says that in his theory? Dalton says that all matter is made up of very tiny particles called atoms, which participate in the chemical reactions. This is the only atoms participate in the chemical reactions, okay? This was absolutely correct. He said that atoms are indivisible and which cannot be created nor destroyed during a chemical reaction. So it is absolutely correct. Some teachers say that atoms can be further broken. It is a drawback. But atoms do not break in the chemical reaction. So if it is written here in the chemical reaction, so it is correct. Atoms break further into subatomic particles like electron, proton, and neutrons. Electron, proton, and neutrons. They further breaks. Okay. They further breaks, but not in chemical reaction. They break in nuclear reaction. They break in nuclear reaction. And in nuclear reaction, the no laws of chemical reactions take place. Like if you, in the chemical reaction, you say that mass can neither be created nor destroyed. But in nuclear reaction, mass can be converted into energy. Mass can be destroyed. So here we will say that if you are talking about the chemical reactions, so atoms are indivisible. Still they are indivisible. Okay, atoms do not break in the chemical reactions. Okay, they still remain same. The bonds are broken. Like for example, 2 hydrogen atoms here we are having and 1 oxygen atoms. So the bonds are breaking there. And now the 2 hydrogen and 1 oxygen atoms are combining to form 2 water molecules like this. So they will be combining like this. So bonds are broken, atoms are not broken. So this is also absolutely correct if we write the word chemical reactions. In the third point, he said that atoms of a given elements are identical. Yes, identical in mass, but here it is incorrect. In case of isotope, it is incorrect. It is a drawback that he said that identical atoms have same mass and same chemical properties. No, if we have carbon 14 and carbon 12, they are identical atoms. Identical atoms, identical atoms of carbon, but have different masses, So and they have the same chemical properties. They have same chemical properties. Chemical properties. So in case of isotopes, this Dalton postulate is incorrect. That the atoms of same elements will have same mass? No, the atoms of same elements can have different mass. So in case of only mass, it is incorrect, but they will have the same chemical properties. So half portion is correct. Like if I talk that this portion is correct, that it is saying that they have the same chemical properties. Okay, they have the same chemical properties. So it is identical property. So it is correct. But identical mass, it is not. It is incorrect. It is incorrect. Same, he said that atoms of different element will have different masses. If atoms are different, they will have different mass. So it is also incorrect. But have different chemical properties, it is correct. Like, for example, if I talk about, like we have like we have carbon 14 and nitrogen. Nitrogen 14. They have same mass, but different atoms. And different chemical properties. Different chemical properties. Like in other example, argon, which is a gas. It is a gas, has 40 mass. And calcium, which is a metal, which conduct electricity, it is solid. It is having 40 mass. So they have same mass, same masses, but is still different chemical properties. Chemical properties. So we'll say that this, what are these type of, they are called isobars. They are called isobars. They are called isobars. Isobars. What are isobars? Atoms of different elements having same mass. Atoms of different elements having same mass, but different chemical properties. Okay. Sorry, but different atomic number. But different atomic number. But different atomic numbers. So in case of isobars, can have they are different atoms, can have same mass. So he said that that atoms of different element must have different mass. No, they can have the same mass. Yeah, here it is correct that if they are different, so they must have the different chemical property. It is correct. So half portion of both third and fourth postulate is incorrect. Okay. Understood? Understood. Next, if I talk about is that atoms combines in a ratio of small whole numbers in forming a compound. So when it is when elements are combining, like in C2, like if I'm having that atoms combine a small whole number, like 2 hydrogen atoms combined with one oxygen atom. So in a chemical compounds, atoms combine in a small whole numbers to form a compounds. So this is the next postulate. And he said that relative number and kinds of atoms are constant in a given compound. Yeah, it is correct. That if you are taking water, the relative number like H2O. So there will be always two hydrogen atoms, two hydrogen atom and one oxygen atom. They will combine to form one molecule of water, one molecule of water. So it is must and mandatory that where irrespective of the where the water has been taken, that it is taken from the pond, lake, sea, rain, water from the river, lake, anywhere. If it is water, then it must have two hydrogen and one oxygen atom. You cannot say that no, London water is going to have three hydrogen and two oxygen atom. No, they will always be going to have. In fact, if the water is found on the moon out of the earth, then it must have the two hydrogen and one oxygen. So it is saying that the relative number and kinds of atoms in a given compound is fixed. Like for example, in carbon dioxide, one carbon and two oxygen atoms will have always there must be two carbon and one one carbon and two oxygen atoms. So this is the law that is being asked, that which postulate of Dalton atomic theory supports the law of definite proportion. So this postulate support law of definite proportion. Definite proportion. Okay. And he asked that which postulate of Dalton atomic theory supports the law of conservation of mass. So this postulate supports the law of conservation of mass. Supports law of conservation of mass. Please note it down, these postulates in your copy fast, because this is the most important question that is being asked from the Dalton atomic theory. Okay, so note it down.
Okay, sir.
So done this one.
Just a second, sir.
Noted down the two postulates. So let's move to the next part. Okay, let's understood the average atomic mass calculation. Okay, average atomic mass calculation is very important. So how we will be able to calculate the average atomic mass? Average atomic mass, average atomic mass has a formula, okay, which is going to have the mass of first element, first isotopes, up, okay, into percentage, its percentage upon 100 plus mass of second isotopes into percentage, its percentage upon 100. It can be written as average atomic mass is equals to A of first upon 100 into molecular mass of A, okay, into the percentage of B isotopes upon 100 into mass of B. So like for example, if we are having two isotopes of like oxygen, and if the questions comes, I have given you these questions in your test paper also. Let's take the test paper. Okay. So here in the test paper, they are the two isotopes. One isotope is 16 of oxygen is carrying mass 16. Another isotope is carrying mass of 18. Okay. And let this is 80% present. Okay, 80%. Then tell me the average atomic mass of oxygen atom. Calculate the average atomic mass of oxygen. Atomic mass of oxygen. So you know that if this is going to, if it is 80%, then it would be 20%. Because if something is 30, then another will be 70. If one is 40, then another will be 60, because this sum is 100. So if it is 80%, then other will be 20%. Okay, got it. Now calculate the average atomic mass of oxygen. Calculate it fast. Are you calculating?
Yes, sir.
You have to write it. The percentage of first one is 80 upon 100 into 16, the mass of first one, plus 20 upon 100 into mass of second is 18. Okay, now calculate it.
Sir, is it 15?
How it will be 15? It will be between 16 and 18. It will be between 16 and 18.
Sir, it's 16.
Let's check here is that you have to write it that this is first you multiply this to you are not going to cut it like this way because you know that division of 100 with 100 is very easy. So don't divide it first. Just multiply 16 8s are 16 8s are 128. You will get 1280. You can cut with 110. Okay, you can cut this 0 with 0. Okay, so it will be 128 upon 10. 128 upon 10 because they both are having plus 18 to the 36 upon 10. Now don't do this one, just add these two. 128 plus 36. You get 8 and 6. 1 carry here. 14. Okay, 2 and 3 is 2 and 3 is 5. 1 6.
164.
Okay. So this is 164 upon 10 is 164 point. Okay. Got it?
Yes, sir.
Now the same type of question comes. Here is another question. If the ratio of the question is being asked. Like if it is chlorine, two isotopes, one is 37, another isotopes of chlorine is 35. And it is present in 1:3 ratio. 1:2. The ratio of this one is 1:3. Then find out their average atomic mass. So in that case, what you are going to do? You don't know the percentage of this one, na? And we have the formula of percentage. You have 1 and 3, so you don't have the percentage. So how will you count the percentage? Just imagine that 1:3 means that 1, if we have 4 equal parts, okay? So out of that 4 equal parts, this isotopes carry 1 part. So that is 1 by 4. It's okay, and its ratio will be, if I convert it into the fraction, so this is 1:3. So out of 4 part, it has 3 parts, which will be 3 upon 4. Now to convert it into percentage, multiplied by 100. You will get 25%, and here you will get 25 into 3 will get 75%. Got it? Now find out the average atomic mass of chlorine, please.
Sir, is it 35?
Calculate it. If it is 25%, this is 25 upon 100 into 37 plus 75 upon 100 into 75 upon 100 into 35. The mass of second. Calculate it. Galvin, are you getting?
Yes, sir.
And Riyaz, you?
Yes, sir.
This is very simple that how you can do. Just multiply these two terms first, okay? Or you can divide it first because they are both are going to have the same 4 at that. When cut the number, if we are getting the same. So you'll get 4
Sir,
here.
I'm getting the same answer, 35.
Just check it, okay? So 1 into 37, when you divide it by 25, you'll get 25 ones are 25 fours. And you will get 25 threes are and 25 fours. So you will have 1 into 37 upon 4 plus 35 threes are 105 upon 4. So that is 1 into 37, you'll get 37. So 37 plus 105 upon 4. So when you add these two, you will get 142. Upon 4, when you divide it, you will get 35.5. Got it?
Yes, sir.
Last question. If we have an isotopes A and B, and it has a ratio of 2:3, okay, calculate it percentage. The ratio of A and B is isotopes is 2:3. What are their percentage?